Hi friends, and welcome to my channel. Let's have a look at problem 493, reverse pairs. So here we are going to share a solution based on binary search. So we are going to share two formats of solutions. One is pure binary search, and the other we use sorted container. More specifically, we are going to use a sorted list. So actually we look at this problem again after we solved problem 24, 26. So in this video, we plan to examine this problem 493 using the same idea for problem 24, 26. So first, let's look at the short statement of the problem. So given an integer array called nums, return the number of reverse pairs in the array. So here the definition of reverse pair is that a pair ij such that ij are in bound and I is strictly less than j, and num I is larger than twice of nums j. So here are two examples. So in example 1, so the output is 2. So you can examine 1, 4 and 3, 4, right? So this is the inequality relation. So in example 2, so the output is 3. So you can examine the three indices pairs 1, 4, 2, 4, 3, 4. With that said, let's also look at the additional constraints for this problem. So first, the length of the nums array is bounded below by 1 and bounded above by 5 times 10 to the power 4. So the upper bound actually defines the problem size. The second constraint is on the range of elements in the nums list, so which is actually a 32-bit signed integer. So with that said, let's also look at the analysis or idea in problem 24 and 26. So actually, the idea is very straightforward. So for each item in nums we look at, it corresponds to an index j. So what we are going to do is to fetch number of previous indices I, such that they can pair with j to form valid reverse pairs. So in some sense, this problem is more direct than problem 24, 26, because in problem 24, 26, we need to make some simple transformations to realize that the two indices in that requirement there can be decoupled. So here, this only involves one list. So with that said, I guess we can directly write the code for this problem. So here I'm going to share two formats of solutions as in problem 24, 26. They are essentially the same solution based on the idea of binary search. So first, I'm going to look at the binary search solution. So for this, basically we follow this idea exactly. So first, I'm going to initialize a result variable. So this is going to count the number of valid reverse pairs. And also, I want to introduce an auxiliary list, which will store the previous nums when we look at the current element in nums. So notice that, so if for each fixed index j, if we want to count the number of indices I that can pair with the current j, so the previous order does not matter. So we can make aux sorted in ascending order. So this is the preparation. So next we are going to do the for loop. So for y in nums. So what we are going to do is that, so we are going to check how many elements in aux is smaller than, so here smaller or equal than the twice of this y. The reason is that in this definition, so the equality relation is a strict inequality. So for this, what we are going to do is first let's look at the index. So let's call it I. So it's bisect. So I'm going to use bisect right. So we're going to bisect, searching for in this aux list, and the target we're going to search is 2y, is corresponding to this 2 times nums g, right? So this index I will give that all the indices left to this index will have a value less than or equal to 2y, right? And then if we use the length of the aux minus this I, we will have the number of indices in front of g, which can pair with the g to form reverse pair or valid reverse pair. So this is going to have an increment for the result, that is the length of this aux minus this I, right? In the aux, what we're going to do is that bisect. So we're going to insert this element. So we're going to insert y because the previous aux will store the previous elements. So this way of doing, so if we look at this in a full procedure or in a global view, so the resulted list in aux is always sorted in the ascending order. So with that said, so we are ready to return the result. So this is a format of solution to this problem. So with that said, let's first do a special case check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with this explained, now let's look at another slightly different format. So essentially they are the same method. So now let's copy this function signature, and I'm going to change this version to be v1. So now we're going to use sorted list. So in using this format, so we're going to initialize a sorted list object, and then we call the bisect rate as a method of that object. So for this, again, we're going to initialize a result which is for counting, right? And then we're going to initialize the aux dictionary, not dictionary, the sorted list. So we're going to do this sorted list. So for this, in order to use this, let me make some import. So from sorted containers, import sorted list. So with this preparation, we are again ready to do the for loop. So for y in nums, then first I'm going to find the I as above, but here what we are going to do is call bisect rate method of this object. So the target we are searching for is 2 times y, and then we are going to increment this result again by the length of the aux minus I. So then we are going to do aux add y, right? So we are going to use this method, and then we are going to return the result. So in fact here we called the length, so we can actually also record the length by introduce another variable. So each time we do a add or we do a insert, so here we can increment that length by 1. So that way we do not need to compute the length again. But this will be fun. So this is the fun detail. So with that said, let's examine this version of solution. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the test cases. So yeah, so that's about it for this specific problem. So in this video, actually, we used the same idea we used to solve problem 24, 26 to look at this example problem. So actually, there should be other ways or formats of solutions it's good to explore. Thank you.